my day job is building open source tools for the federal government with a group called 18F. But this was a side project that I did where I've been interested in playing with gesture, and when most people say gesture and think of mobile, they interpret it as kind of interactions on that 2D surface, right, of a swipe or a pinch or something like that. But that's not really taking advantage of the device and the fact that it's not attached to anything. It doesn't have to be like laying flat on a desk or anything like that. So I think Matt may have overhyped my demo, but I didn't tell him much because it really only does one thing. But the first thing I wanted to, I tried to play with was, okay, what if I could have some sort of interface where I'm actually using my mobile device, using my phone, to control something on my screen and actually treating that mobile device like a controller. So I stole a model viewer in 3JS that takes an STL file, which is a format that's common for 3D printing and other sort of 3D modeling sorts of uses. And I'm rendering it on the screen. That's basically their demo straight out of the box. What I added in was a mobile view. So I visit a slightly different page from my mobile device, and now I'm actually able to control using the gyroscope. And they're kind of small, but there's a couple of arrows on there where I can actually move the thing around the screen and control zoom. It even works with multi-touch. It's a little jittery on this Wi-Fi, but on a local network, it's usually pretty good. So yeah, so that was like pretty fun. And it actually ended up like touching a lot of things that I didn't expect it to. In the sense that there's 3JS and Canvas, the 3D rendering context, on this viewer page. So it's able to load a model, and I have a few arbitrary models in there, but it can accept any STL file. And so there's this rendering piece which loads the STL file, converts it into a mesh, throws it on this canvas. Then there's the controller piece. So this is a different page being served from the same server, and using gyroscope events. So mobile devices give you on orientation change events, and so you get something fired every 20 or 30 milliseconds or something like that really quickly, saying, okay, the device is in this orientation, the device is in this orientation. So then using Node and Socket.io to actually transmit that information from the mobile device to the viewer. Any questions? I can kind of walk through the code, but that's really it. It was just kind of getting this connection working. Any questions before I keep going? Yeah.
What's next? Where do you go from here?
Well, I don't have any $1 million ideas, but if you do, let me know. Yeah, I want to play more with these sort of interfaces where the phone is not just assumed flat.
Yeah.
Yeah, I don't know. I had an idea for a bop it kind of game or something like that on the mobile device where you shake it, or something where you're actually interacting with the environment around you. If anyone's ever played Space Team, I really like that kind of in-person interaction. Of actually using the phones in the sort of non-traditional way. So I don't really have anywhere that I want to go with this necessarily. The code is open source, and I'll show the link at the end. But yeah, I was kind of pleased as a proof of concept. Yeah.
What about multiple devices?
It theoretically could work. So I have, it'll be really hard to see up here, but I have Chrome here with device emulation, I don't know why it's all jittery, but I'm able to not only control it from there, but able to control it from this device as well. Theoretically, you could have multiple models. You could like have jousting or something like that. That could be a fun way to go with it. I don't know. I haven't really thought about it, but theoretically, it would be pretty easy to extend. So yeah, so something I took an animation class in college, like a computer graphics class, and did not do well, but was sort of forced to go through a lot of these things with 3JS, and one thing I learned about was Gimbal Lock. So if anyone, I'm probably going to butcher the explanation, but essentially, if you think about a device or an object having 3 degrees of rotation, right? Like pitch, yaw, and roll. If you simply express the rotation like from the phone applied to that object with those 3 degrees of rotation, which is called Euler angles, I'm pretty sure that's the same thing, you run into something called Gimbal Lock. So if you do like what I just did and try and do a 360, you'd see it flip halfway through. You've probably seen this in like crappy video games. But the reason has something to do with, and I have pictures, I can't really explain them, but basically you have these three degrees of rotation, and when 2 degrees of rotation align, you're then not able to like rotate, so it has to flip to like get past it. My hand-wavy explanation, but so I end up using something called quaternions, which I believe is represented more as a vector with rotation, and so that doesn't have the Gimbal Lock problem, which made the like flipping smooth.
So a couple of years ago, with some friends, we made a similar idea, like a game where 2 people could be controlling what goes on the screen, and with fingers you control the paddle. Like a game of Pong.
Why aren't you presenting then?
Because it's gone. But it's an interesting idea. Like you can also run a physics engine on the server, and if you play the game, the server is the judge that's running.
Yeah, another at a hackathon, I had worked with someone on a game that's like like Pong in a circle, and so that was another kind of phone interface idea. It was like using the phone almost like a steering wheel, to like. Yeah, do something like what we're talking about.
How did you do the mobile?
So it's just a mobile website actually, and there's not a whole lot to it. I can show a little bit of the code, but the controller is I'm using Browserify on the front end, so it looks like Node, but it's actually running on the client. So this controller code loads the device orientation handler. So when the device orientation event fires, it's just taking that event and taking the alpha, beta, gamma, which is those 3 degrees of rotation, and sending them through socket.io. And then socket.io is just then broadcasting it back and forward to the to any of the viewers. So theoretically, you could have a bunch of the viewer open on many different browser tabs, and all of them would stay in sync. So there's not anything clever with sessions or whatever. Oh yeah. So it's only one direction actually. So because this doesn't have to know about anything that the viewer does. Like this is just sending events really. So yeah. So right. So from the client, I'm listening to device orientation and sending that as on the gyro channel, I believe is the terminology. And then similarly for drag events, so the kind of panning and then the zooming, sending those events through the drag channel. And the node code is actually the simplest part of this whole thing. It is just well, anyway. Anyway, server. Okay, so yeah, so when socket.io gets a connection, I'm just wiring up, this channel, or both of those channels, and saying, anytime there's an event on that channel, just broadcast it. So it's just acting as a connector. It's really not doing very much at all. So yeah, then the client receives the gyro events and interprets those as the rotations, and then gets the drag events and interprets those as displacement of position. Yeah, exactly. Yeah, so it's applying that to the mesh, which in the viewer, I believe is here. Yeah, so when this is the viewer code now, so when it gets a gyro event, let's see. Yeah, it is just holding on to the device orientation, and then the render event, with every frame is saying, okay, what should, because it's not like offsets, it's not like, I move this, for orientation at least, it's absolute, right? So I can just store whatever the rotation is that the most recent rotation is, and that's going to be the position of the rotation of the mesh. With the drag, I'm using offsets, so it was moved like 10 units in this direction or whatever. So that I'm just able to store that position, and I don't know, there's some messy code in here that does the rotation in here. I think it creates the Euler rotation, which is those three angles, and then applies that to the quaternion, which is like the vector. Yeah.
Are you going zoom in, zoom out? In this
Yeah. So I think with that, I'm controlling the position of the camera. I think. Yeah. Or it might have been. I don't remember what I ended up doing, like either the camera or the object itself, but.
That's all part of the
Yeah. Mm. Any other questions?
Is this on GitHub?
Yeah. So that is a good outro. Yep, that's my name, that's my Twitter's, and that's the repository where you can find this. So thank you very much. Happy to talk about it afterwards.